Alright, we need to give the domain and range. Remember that domain is the x values, and that is a measurement of how far left and right this goes. And the range is the y values, and that's a measurement of how far up and down these go. So number one, you can tell by these arrows that this graph goes forever to the left and forever to the right, so the domain is going to be all real numbers. It would also appear that those graphs, it's kind of hard to tell, but I think that those graphs or those arrows are also kind of pointed upwards and downwards as well. So I think that the range here is going to be all real numbers also. Probably the safest answer there. Number two, the domain, we have kind of an issue right here with that open circle. So the domain is the x values, and this graph starts at -4 and goes, that way to the right. So that's all numbers greater than -4. Now notice that I did not put the or equal to there because of the open circle. So similarly for the range is all numbers greater than however low this little dot is. This point is down to -1, so that's going to be my range. That's it. Number three, we kind of have this starting point right here, and so that is all x numbers greater than that number. Again, the idea there is that this graph starts at -4 and goes forever to the right. The range is all the y numbers greater than or equal to however high up that dot is, which is at 0. So done there. Number four, again we have this open circle situation. Remember that really means that the graph isn't there. That's kind of like it gets close to that kind of point. So it's not included in the graph. So the domain is all x numbers just greater than, and notice this line goes to the right, so that's all numbers bigger than -4. And the range is all of the numbers smaller than, however high up the graph goes, which is 3. And that's it there. Again, both of those were just greater than and less than signs because of the open circle. Done. Okay, number one, we have the volume of a right circular cone with a radius r and a height h shown below, and they have given us a formula right there. Kind of continues on to the next line. So they tell us the formula, volume is equal to 1/3 times pi times r squared times h. And it says that r is the radius and h is the height. From there, they tell us a couple things. The volume is 142, and the height is 8.5. So essentially, they've given you a couple of these numbers to fill in. So the number 142 is a volume, so that would go here. And then we do not know the radius. The question is asking us about the radius, but it does tell us that the height is 8.5. Alright, so we've got those numbers filled in. Honestly, at this point, this is just kind of a strange solving problem. We need to solve for r. Actually, on second thought, solving that would be pretty rough. Just lots of decimals and stuff. Lots of stuff going on there, especially with the pi. Certainly not impossible to solve, but I have an idea. Since this is a multiple choice question, we know the answer sitting over here. We just need to probably grab these numbers and one at a time put them in place of r and see if we calculate something close to 142. So basically, I would check and I would go, okay, 1/3 times pi times and I would check, the number 2 squared times 8.5, and you would just grab a calculator and do that. Calculator tells me that comes out to be about 35.6, which is clearly not the answer. Remember, we're looking to get 142. So I'll go check another one. And I would do 1/3 times pi. By the way, I'm just using my calculator. I'm just using 3.14, figuring that'll probably get me close enough. Times 4 squared times 8.5. Just grab a calculator and do that. Sure enough, that gives me 142.3 or something, which is close enough, and I would go ahead and say B is our answer. Done. Alright, number 2 here is going to describe a triangle. A boat departs Port Isabel, Texas, traveling to an oil rig. The oil rig is located 9 miles east and 12 miles north of the boat's departure point. So I've got my little boat. Here's my boat. It's got a sail. That boat is, and there's an oil rig that is 9 miles east. So east is like this way. So that is 9 miles. And then 12 miles north. My drawing is not to scale. And it's asking how many miles the oil rig is from the departure point. So to me, that is a straight line distance straight across there, and that is a right triangle because of the north and the east. So that is probably best done with the Pythagorean theorem. So a squared plus b squared equals c squared is what we're up to. It turns out this would be like my a, this would be like my b, and that's my c. So basically we are going to do 9 squared plus 12 squared equals c squared. That's 81. It's 144. We need to add those up and square root them. 144 and 81 is 5, 2, 1, 225. So, and then we would square root both sides, and the square root of 225 turns out to be 15. Just for the fun of it, back in geometry, you guys memorized, or were asked to memorize probably, something that we call a 3, 4, 5 triangle. In other words, a lot of things on the ACT are based on this triangle right here with those proportions. 3, 4, and 5 work with the Pythagorean theorem. And so basically, you can see that this side, sorry again, this drawing wasn't scale. You just basically notice that if I take the 3 and multiply by 3, I get 9. If I take 4 times 3, I get 12. And so similar triangles, 5 times 3 would give me 15. And that would be the quickest way that I could get that answer. If you're going to do well on the ACT, you would do well to walk into it knowing about 3, 4, 5 right triangles. There's some other common numbers too, like 5, 12, and 13. They're called Pythagorean triples. Look them up.